Engineering is the purposeful use of science. Science provides an understanding of natural phenomena. Scientific study involves experiments. Um, so, and scientific laws are concise statements or equations that explain the experimental data. And laws of physics is like a layer of abstraction between the experimental data and the practitioners who want to use specific phenomena to achieve their goals without having to worry about the specifics of the experiments and the data that inspired the laws. So, abstractions are constructed with a particular set of goals in mind and apply when appropriate constraints are met. So, for example, like Newton's laws of motion are simple statements related to the dynamics of rigid bodies, to their masses and external forces. They apply under certain constraints. For example, when velocities are much smaller than speed of light. So, scientific abstractions or laws like Newton's are simple and easy to use and enable us to use the properties of nature. So, electrical engineering and computer science or electrical engineering is one of many engineering disciplines. Electrical engineering is the purposeful use of Maxwell's equations or abstractions for electromagnetic phenomena. To facilitate our use of electromagnetic phenomena, electrical engineering creates a new abstraction layer called lumped circuit abstraction, which is a connection between physics and electrical engineering on top of Maxwell's equation. So, electrical engineering and computer science is an art of creating and exploiting successive abstractions to manage the complexity of building useful electrical systems. Computer science is one type of electrical system. So, abstraction mechanism is powerful because it can make the task of building complex systems tractable. For example, force equation F equal to ma. So, when we want to calculate acceleration and force and mass are given, so this equation will help us to disregard size, shape, density and temperature, which is immaterial to calculation of object acceleration. So, we ignore a myriad details of experiments and observation that led to force equation and accept it as a given. Thus, scientific laws or abstractions allow us to leverage and build upon past experience and work. So, over the past century, electrical engineering and computer science developed a set of abstractions that enable us to transition from physical sciences to engineering and build useful complex systems. So, a set of abstractions that transition from science to engineering and insulate the engineer from scientific minutiae are often derived through the discretization discipline. Discretization means lumping. Discipline is a self-imposed constraint. So the discipline of discretization, we choose to deal with discrete elements or ranges and ascribe a single value to each discrete element or range. We ignore the distribution of values within a discrete element. Systems built on this principle operate within appropriate constraints so that the single value assumptions hold. For example, lumped circuit abstraction is fundamental to electrical engineering and computer science and is based on lumping or discretizing matter. Also, Newton's laws of physics is based on discretizing matter. They describe dynamics of discrete bodies of matter by treating them as point masses. Spatial distribution of properties within the discrete elements are ignored. So, also like digital systems use the digital abstractions based on discretizing signal values, and clock digital systems, they are based on discretizing both signals and time. Digital systolic arrays, they are based on discretizing signals, time and space. So, if we put a set of abstractions on the x-axis and on y-axis, if we put succession of abstraction layer piling one above one other that facilitate building complex computer systems and control systems, we will find that physics has a set of abstraction that leads to electrical engineering, and electrical engineering abstractions manage complexity of building large systems. And lumped circuit element, they are used as an abstract representation or model of piece of material with complicated internal behavior. Circuit is an abstract of interrelated physical phenomena, and op-amp simplifies building of bigger analog systems. They are made up of primitive discrete elements. Similarly goes for logic gates, digital memory, digital finance